Okay, the next convergence test we're going to look at is known as the alternating series test, and you can find this in section 9.6 in the textbook. And so first I just want to say what an alternating series is. So it's a series of the form b1 minus b2 plus b3 minus b4 and so on. So you see this alternation in sign. And here I say where b sub n is greater than or equal to 0 for all n. Okay, so note that in order to get a true sign alternation, I want the bn's to all have the same sign. If that weren't the case, right, then you may not actually get a true sign alternation, right? Like let's say b1 were positive but b2 were negative, then subtracting b2 you'd really be adding something, right? But if the bn's all have the same sign, then you will have a true alternation in sign, okay? Hence the name alternating series. All right, so here's an example. The sum of negative 1 to the n minus 1 times n, all divided by n squared plus 4. So expanding there, we get a fifth minus 2/8 plus 3/13 minus 4/20, and so on. Okay, so this is an alternating series. And here, b sub n, which note b sub n is the part of the thing you're summing that's multiplying this sign alternator, the negative 1 to the n minus 1. So here, b sub n is n over n squared plus 4. Okay, now this example, 1 plus 2 minus 3 minus 4 plus 5 plus 6 and so on. This is not an alternating series, and that's just because we don't have an alternation of sign from term to term, right? It goes plus, plus, minus, minus, plus, plus, and so on. All right, so now what does the alternating series test say? It says, let b sub n be a sequence in non-negative terms, so b sub n is non-negative for all n. The alternating series, right, which is b1 minus b2 plus b3 minus b4 and so on, converges if the following two conditions hold on this sequence b sub n. The first condition is that b sub n plus 1 must be less than or equal to b sub n for all n. So in other words, the sequence b sub n is decreasing. And the second condition is that b sub n approaches 0 as n approaches infinity. All right, so now to illustrate, let's consider this series. So we're summing negative 1 to the n minus 1 divided by n. N starts at 1 here. So this is 1 minus a half plus a third minus a fourth and so on. So note that this looks just like the harmonic series, except now we have this alternation in sign. And for that reason, this is called the alternating harmonic series. All right, so here, b sub n is just 1 over n, which is clearly decreasing. So the first condition is satisfied. And it clearly goes to 0 as n approaches infinity. So the second condition is satisfied. And so the alternating series test implies that the alternating harmonic series converges. Okay, now in chapter 10, we'll be able to show that this series actually converges to the natural log of 2. But in any event, we'll go ahead in the next video and look at some more examples of how to apply the alternating series test. All right, thanks.